this is your 3-4 notes. So if you want to write this down somewhere on top, it's just equations of lines. So again, this is kind of a review from algebra. So it should be an easy refresher. If not, then hopefully I do a good job explaining it. Okay, so here we go. First thing is your slope-intercept form. That's just y equals mx plus b. Okay, this is the one that you want to use whenever we have to graph equations, because you have your y-intercept, which is your starting point, and you have your slope, that's your rise over run, and tells you where you need to plot the other points. Okay, the second one that we have is standard form. That's your ax plus by is equal to c. And the last one that we have is your point slope form. Okay, and that is going to be your y minus y1 is equal to m times x minus x1 minus x1. So you want to use that whenever they give you the slope and a point. Okay, so first one we have is that my slope is 2, my y-intercept is -3. They want the slope-intercept and the standard form, and we have to graph it. Well, slope-intercept is really nice because slope-intercept is y equals mx plus b. I have my slope, I have my y-intercept, so we're just going to plug it in. Y equals 2x minus 3. Okay, for standard form, all right, get over here kind of purplish color. Okay, for standard form, what we have to do is we're going to use our slope-intercept, y equals 2x minus 3. And we're going to put this into standard form. So x and y are going to go on the same side. And why did I use purple? It's supposed to be red. Pretend this is red. Okay, so x has to go on the same side as my y. When this is a positive 2x, when I move it over, it's going to become a negative. So I have negative 2x plus y is equal to -3. You are not done. There are two no-nos, and we're going to write this back up here. There are two no-nos. I call them no-nos. Okay, there are two no-nos when you have standard form. One of them is you can have no negatives. The other one is no fractions. And we're talking about the number in front of the x, the number in front of a, okay? So a right here has two no-nos. A cannot be a negative, and it cannot be a fraction. So here, if you notice, your coefficient in front of x, it's a negative. So to get rid of the negative, what we're going to do is we multiply everything here by a -1. So everything gets multiplied by a -1. And what we end up with is 2x minus y is equal to 3. And there's your standard form. Okay, last thing that we have to do is we have to graph this. So my slope is 2. So that's my rise over run. And remember, whenever you have a whole number, just put it over 1 to make your rise over run. And my y-intercept is -3. I'm going to write that as an ordered pair, 0, -3. Okay, so we're going to go ahead and plot this. So I have 0, -3. So 0, 1, 2, 3. So 0, -3. And my rise over run is going to be up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And to finish my graph, instead of going up and to the right, we're going to go down and to the left. So down to the left 1, down 2 and to the left 1. Once you have your points, then you're going to go ahead and connect your dots. And again, don't judge me on my lines because it's very hard to draw a straight line on here. Okay, so there's my line. And that's it for the first one. Okay, second one, they give us our slope and they give us a point. Notice your point's not your y-intercept, so for this one, you're going to use your point slope formula. So let me go back to my purple. There we go. My formula says that we do y minus y1 is equal to m times x minus x1. Okay, so I'm going to label this. This is my x1 and my y1, and my slope is already labeled. So we're going to go ahead and we're going to plug this in. So y minus y1's a -1 is equal to m, which is 1/2, x minus x1 is 4. Okay, minus and a negative become a positive. So I'm also going to distribute this 1/2. So I have y plus 1 is equal to 1/2 x, and half of 4 is 2, so minus 2. And then what I have to do is subtract 1 from both sides. So minus 1, minus 1. And what you end up getting is y equals 1/2 x minus 3. Okay, so that's my equation, and I'm going to rewrite that in my green just so I can see here that this is in my slope-intercept form, because that's the column that we're in, is slope-intercept form. And from here, what I can do is I now know how to graph, okay, because now I know my slope is 1/2, which is my rise over run. And I also know that my y-intercept is -3. And I'm going to write that as an ordered pair, which is 0, -3. Before I graph though, I'm going to go ahead and put this into standard form. So we have y equals 1/2 x minus 3. Okay, so I gotta get my x and y on the same side, so I'm going to go ahead and move this x on over. So we have -1/2 x plus y is equal to -3. Okay, because when you move it over, you gotta change the sign. Before you say you're finished, you have to check for your no-nos. So I look here and I see in front of my x, that's the only one you care about, I have 2 no-nos. I have a negative and I also have a fraction. So to get rid of this, you have to multiply everything by a negative, because that gets rid of the negative, and then by the denominator, because that gets rid of the fraction. So multiply everything in here by -2. So when we do that, we end up with -2 times -1/2 just gives me x. -2 times y gives me -2y. And -2 times -3 gives me a +6. So there's my standard form. All right, last thing I do is plot the graph. So we have my y-intercepts at 0, -3. So 0, -3, 1, 2, 3. And my slope is 1/2. So up 1 over 2, up 1 over 2, up 1 over 2, up 1 can't go any further. So instead of going up and to the right, I'm going to go down to the left. So down 1 over 2, down 1 over 2, down 1 over 2. And then we go ahead and connect the dots. So I'm going to connect my dots. Oh boy. Trying to make this straight of a line as I can. Yeah, you're going to have to forgive me for how ugly these little lines are. Alright, so there you go. So there is your graph, and that's all you have to do for the second one. Okay, last one like this. Here we're given 2 points, okay? So the first thing that we're going to have to do is we're going to have to find the slope, because we can use a slope at one of these points for our point slope formula. But before we can plug anything in, you have to get the slope. So I'm going to go ahead, I'm going to use my purple color again. I'm going to label this x1, y1, x2, y2, and I'm going to go ahead and find my slope. So my slope, m, is equal to y2 minus y1 over x2 minus x1. Plug in my numbers. Y2 is a -2, minus y1 is a 2, over x2 is a -3, minus my x1 is a -1, minus and a negative become a positive. So my slope is going to be -4 over -2. And so my slope is just a +2. All right. Now what we're going to do is we are going to use 2 things. We're going to use this first point right here. We're going to use my slope right here. and we're going to plug those two in to my point slope formula. So my point slope formula says y minus y1 is equal to mx minus x1. Okay, so I have y minus my y1 right here is 2 is equal to m. My slope I just found is 2 times x minus x1. My x1's a negative 1. Don't forget, minus and negative become a positive. Okay, so I'm going to distribute this 2 here. So I have y minus 2 is equal to 2x plus 2. Get y by itself, so I'm going to add 2 to both sides. So we end up with y is equal to 2x plus 4. And again, I'm going to rewrite this in my green because it's in my slope-intercept form. Okay, and from this, I know two things. I know my slope is 2, which is my rise over run. And I can put that over 1. And I know my y-intercept is 4. So I'm going to write that as 0, 4. Before I graph this though, I'm going to go ahead and put it in standard form. So I have y equals 2x plus 4. Move my 2x over. Since it's positive, it's now going to become negative. So negative 2x plus y is equal to 4. Okay, and what I'm going to do is I'm going to check my no-nos. I see I have one no-no right here. It's a negative. So to get rid of the negative, you multiply everything by a negative 1. And so once you multiply everything by negative 1, you end up with 2x minus y is equal to negative 4. So there's your standard form. Alright, and the last thing we have to do here is just plot our points. So I start with my y-intercept, that's your starting point, 0, 4. So 0, 1, 2, 3, 4. And then my slope says I'm going to go up 2 and over 1. So up 1, 2 over 1. Up can't go anymore. So instead of going up and to the right, I'm going to go down to the left. So down 2 over 1. 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 And then again, we're going to make a lovely line here. Kind of. Better than the last one. And then that's it. That's all that you have to do. Okay. And the last problem that we have here is a word problem. It says Jerry's current satellite television service charges a flat rate of $34.95 per month. So $34.95 per month for the basic channels, and additional $10 per month for your premium channels. Okay, so $10 per month for each premium channel. Then you have a competing satellite television service. They have the flat rate of $39.99 per month, and they have an additional $8 per month for each of your premium channels. Write an equation in slope-intercept form that models the total monthly cost for each satellite service, and P is given the number of premium channels. So we have two separate ones. The first one, my total cost, I'll put C1 because we have two companies. Okay, so the cost for this first company is $34.95 plus $10 for your premium channels. And the second one, we have the cost of $39.99 plus $8 per month. Per your premium channel. Okay, so slope-intercept form, this is okay. If you want to put it in the y equals mx plus b, you just have C1 is equal to 10p plus 34.95. Okay, and the cost for the second one would be 8p plus $39.99 for your second one. Okay, so that's how you can rewrite this. Y equals mx plus b. It's just so that your variable comes first and your constant will be back here. Right? Either way, though, I will accept it because they both are going to be in slope-intercept form. So that's it for your 3-4 notes, and y'all can go ahead and get started on your Alex homework.